Let's move on to talk about molar mass. Right? Now, the molar mass of a substance is the mass of 1 mole of the substance. Okay, so let me give you an example. The mass of 1 mole of an element is the AR of the element. Right? So if the AR of sulfur is 32, the mass of 1 mole of sulfur will be 32 grams per mole. Okay, so now it might seem a little bit confusing, so let me explain. Okay, AR of sulfur is 32. Now you notice that we don't put any units because it is a relative mass. Okay, however, if I ask for the actual mass of 1 mole of sulfur, you have to tell me it is 32 grams per mole, right? The unit is G/mole. Okay, and the reason for this is because now we are writing out the actual mass of the substance found in 1 mole of sulfur. Okay, hence what this means is in 1 mole of sulfur, right, there are 6.02 times 10 to the power 23 sulfur atoms, and these 6.02 times 10 to the power 23 sulfur atoms weighs 32 grams. Okay, that's what it means. Alright, hence when we look at the mass of sulfur, we say it is 32 grams per mole. Alright, okay. The mass of 1 mole of a compound, likewise, it's the MR of the compound. Okay, so earlier on, if you remember our calculation for the MR of CO2, 44. So hence, 1 mole of CO2 has a mass of 44 grams per mole. Okay, now in this particular chapter, there are a few triangles, I would say, that you will need to remember. Okay, so I'm going to scroll back up to the earlier one here. This is triangle number 1. Okay, comparing particles to Avogadro's constant. Right, now we go on to the second and also one of the most important triangles that you will need to know. Right, the triangle that equates mole with mass and molar mass. Okay, so let me explain the triangle first before we go to the practice. Alright, now in order for us to calculate the number of moles of a particle, right, usually we will be given the mass, and the molar mass can be determined by looking at the periodic table. Okay, so sometimes questions can ask you to calculate number of moles, sometimes question can ask you to calculate mass, sometimes questions can ask you to calculate molar mass. Okay, so let's take a look at some examples. Part A. Calculate the number of moles of CO2 in 132 grams of carbon dioxide. Okay, so this is the mass that's already given. Okay, so over here, if we come back to the diagram, I'm going to use a different color, okay? So we have the mass, right, given to us. We have the molar mass because we can just look at the periodic table. So now we calculate number of moles. We just take mass divide by MR. So earlier on, we've calculated that the MR of carbon dioxide is 44. So 132 divided by 44. Just need to press your calculator. Okay, this will be 3.00 mol. Okay, now please take note of something very important when you write the unit. Okay, the unit for number of moles is simply just mol. Okay, a lot of us tend to have the tendency to write mols, right? Okay, but there's no such thing as mols, right? Because if similar to how you measure mass, right? If something weighs 1 kilogram, you write 1 kg. But if something weighs 50 kilograms, we don't write 50 kgs. Correct not? We just leave it as 50 kg. Okay? So this 50 kgs is wrong, right? Because we shouldn't have the s inside. Okay? So likewise, mol stays as it is. Okay? Let's try the other one. Now we are going to do a bit of manipulation. The question asks for you to calculate the mass of N2 in 0.25 mole of nitrogen gas. Okay, so let's come back to the triangle again. Now, this time round, I'll use green. This time round, the number of moles is given. the molar mass can be calculated from periodic table, okay, and the question wants us to determine the mass. Okay, so what we need to do is to take the number of moles multiplied by molar mass. Okay, so number of moles is given in the question, 0.25, multiplied by the molar mass of N2. So if you look at the periodic table, each nitrogen is 14, and there's 2 of it, so I multiply by 2. Okay, can? Right? So likewise, press calculator, 0.25 of 28. That will be 7.00 grams. Okay? Now, last one requires a little bit more manipulation. Okay, think we will stop at page 5 for today's recording. Okay, so that it's not too much information. Alright, so for all of you, I just need you to watch the video until page 5, and then after that we will continue page 6 when we see each other again. Okay, now for this question, calculate the number of molecules present in 4.9 grams of sulfuric acid. Okay, now the question asks for number of molecules. Please do not confuse this with number of moles. Okay, so over here we need to make use of two triangles, right? The first one is this particular one, okay, and the second one is the one earlier on, right? Because here the question is asking us to calculate the number of molecules. Alright, so how can we make connections between these two triangles? Okay, first we calculate number of moles first. Alright, so straight away we have mass given to us, and we can simply calculate the molar mass of sulfuric acid. Okay, so to determine the number of moles, I take mass divide by molar mass. Okay, so 4.9 divide by the molar mass of sulfuric acid, 2 hydrogen plus 1 sulfur plus 4 oxygen. Okay, so I press my calculator. 2 plus 32 plus 64, 4.9 divided by 98. Okay, 0.05 mole. Alright, so this is the number of moles of sulfuric acid. Okay, so using this, I've already settled the second triangle. Now I need to calculate the number of molecules. So if I go back to the first triangle, right, I have the number of moles. I just need to multiply by Avogadro's constant to give me the number of particles. Okay, so come back here again, 0.05 multiplied by 6.02 times 10 to the power of 23. Okay, so this is 0.301 times 10 to the power of 23. Okay, or we can change it, right, to 3.01 times 10 to the power of 22. Okay, as per how we usually write our standard form. 3.01 times 10 to the power of 22 molecules. Okay, so that is how we work out such calculations using the two different triangles given to you. Alright, okay, the last part for this recording, we'll move on to molar gas volume. Okay, now in molar gas volume, okay, Avogadro is a scientist, right? And according to his research, okay, 1 mole of any gas occupies the same volume of 24 dm³ at room temperature and pressure. Okay, this is called the molar gas volume or molar volume. Alright, so regardless of what gas it is, as long as it is 1 mole, it occupies 24 dm³. Okay, now for the benefit of some of us who cannot remember what dm³ is, let me talk about that first before we move on to the calculation. Okay, dm³ represents decimeter cube, right, or cubic decimeter. Okay, so what this means, 1 dm³ equals to 1000 cubic centimeters. Okay, this is an important conversion that you need to know. Right? So if I have 24 dm³ of a gas, that means I have 24,000 cubic centimeters of this gas. Okay? Alright, so let's jump right into the third triangle that we're going to introduce to you today. alright, which is this. Okay, the number of moles is equivalent to the volume of a gas divided by the molar gas volume. Okay, how do we make use of this triangle? Let's take a look at part A. Calculate the volume of 3.3 moles of sulfur dioxide at room temperature and pressure. Right, so 3.3 moles is the number of moles given to you. Sulfur dioxide is the gas. Right, but regardless of what gas, it should occupy 24 dm cube. Okay, so the total volume will just be 3.3 multiplied by 24. Okay, so this is a very simple calculation. 3.3 multiplied by 24. Okay, 79.2 cubic decimeters, right? dm cube. Okay, because 24 is in dm cube. Alright, now next question. Calculate the mass of 36 dm cube of ammonia at RTP, room temperature and pressure. Okay, so over here, the question requires 2 steps, right? But before we do the second step, we work with what we have first, okay? 36 dm cube is the volume, right? So I can find number of moles first before I use the next triangle, the next formula, okay? So in order to find the number of moles of ammonia, I just take 36 divided by molar gas volume, which is 24. Okay, so 36 divided by 24, 1.5 mole. Right, now using this 1.5 mole, can I find the mass of ammonia gas? Yes, right, because if I scroll back up again to this triangle, right, I just need to take the number of moles that I've already calculated, multiply by the molar mass of ammonia gas. Okay, so back here, mass equals to mole multiplied by mR. Okay, which is 1.5 multiplied by ammonia gas, 14 plus 3 times hydrogen, like that. Okay, so this totals up to be 17, right? So 1.5 times 17, okay, 25.5. Now look back at what you're calculating, because it's mass, so we leave it as grams. Okay, last question. Calculate the volume occupied by 1.2 times 10 to the power 24 atoms of argon. Okay, so over here again we need to manipulate this information. So we go back to the earlier triangle, which is this. You are given the number of particles, you divide by Avogadro's constant, you can get mole. And once you have the number of moles, we can go back and use the other mole triangles to do my calculation. Okay, so first, 1.2 times 10 to the power 24, I can find number of moles just by dividing by Avogadro's constant. 6.02 times 10 to the power of 23. This should be about 2 moles. Okay, now with this information, moles of argon, this one, okay, how do I find the volume of argon? So I come back to this triangle. I have the number of moles, I just need to multiply by 24. Okay, so 2 multiplied by 24, that should give me 48 dm cube of argon gas. Okay, so I will not continue the rest of the pages, okay, but just to do a quick summary of what we have talked about today, right? First, we introduce what AR and MR is. Okay, relative atomic mass and relative molecular mass. We say that this is a comparison with a common atom known as carbon. Alright, we learned how to calculate an average of all the isotopic masses to explain why some masses have decimal places, they are not whole numbers. Okay, next, we learn how to calculate relative molecular mass by adding the mass of all the atoms together, right? Next, we calculated percentage mass of an element within a compound. Following that, we calculated the actual mass of an element within a compound, right, given the total mass of that particular compound. Okay, Then we introduce the term mole, right, as a group of particles similar to dozen, similar to pair. Okay, so mole is 6 times 10 to the power of 23, right? Then we were introduced to 3 different mole triangles. The first one is to compare moles with the number of particles and Avogadro's constant. Okay, the second triangle is to compare moles with mass and molar mass. And the third triangle is to compare moles with volume and molar gas volume. Okay, now for the next part, page 6 onwards, we are going to look at concentration, how to calculate concentration, right? And this should be something that is familiar to you already because you have learned about rate of reaction and how concentration changes, right? Subsequently, we are going to learn how to derive empirical and molecular formula. So don't worry about this term, we'll introduce it when the time comes. Okay, and finally, we are going to do a bit more practice questions on all this. Alright, okay, so thanks for watching. I will see you on, I think, Tuesday, right, for us to continue with more calculation. Okay, thank you.